The universe is vast. It is older than we can truly imagine. Billions of galaxies stretch out in every direction. Each galaxy contains billions of stars. And many of those stars have planets orbiting them. Our own Milky Way galaxy is just one of countless others. It's a swirling city of stars, gas, and dust. When we look up at the night sky, we are looking into an immense cosmic ocean. The sheer number of worlds out there is staggering. It almost seems impossible that we are the only ones asking questions. It feels like someone else should be out there looking back at us. So, where is everybody? This is one of the biggest questions in all of science. The famous physicist Enrico Fermi asked it during a casual lunch conversation decades ago. His simple question gave birth to a profound puzzle. We call it the Fermi paradox. The universe is so big, so old, and has so many potential homes for life. So, statistically, intelligent life should have appeared many times over. What if the evidence for alien life is not a message but an artifact? Imagine exploring a deserted island and finding no people. But you do find the remains of a great city. Now imagine this on a cosmic scale. Instead of a city, we find a star that has been dismantled. Instead of empty streets, we find a galaxy that has been re-engineered. These would be galaxy-scale ruins. They are the ultimate sign that we are not the first. These cosmic ruins would be the work of truly advanced civilizations. We call them Type 3 civilizations on a scale invented by astronomer Nikolai Kardashev. A Type 3 civilization would be a master of its own galaxy. It could harness the energy of every single star within it. It could move stars around like chess pieces. It could build structures that dwarf planets and suns. Such a civilization would be like gods to us. Searching for galaxy-scale ruins is not science fiction. It is a real and active field of scientific inquiry. Astronomers around the world are engaged in this ultimate treasure hunt. They are not just listening for radio signals anymore. They are looking for physical evidence of cosmic engineering. They use our most powerful telescopes to scan the skies for anomalies. This search is a massive undertaking. It's like looking for a single strange brick in a city made of trillions of bricks. One of the key methods is to look for waste heat. Any advanced civilization, no matter how sophisticated, must obey the laws of physics. And one of those laws says that any use of energy produces waste heat. A civilization harnessing the power of a galaxy would produce an enormous amount of it. This heat would be radiated away as infrared light. So, astronomers search for galaxies that glow unusually brightly in the infrared spectrum. A galaxy that is unnaturally warm could be a signpost. So how do we actually look for these cosmic relics? It is a task of immense scale, requiring incredible technology and patience. We cannot simply point a telescope and expect to see the gleaming towers of an alien city. Instead, we conduct large-scale surveys. These surveys scan huge patches of the sky, collecting data on millions or even billions of objects at once. We can then use computers to sift through these vast databases, looking for anything that stands out as odd. This is where the real detective work begins. A project called Vanish is looking for stars that were there once, but are now gone. They are comparing old astronomical photographic plates from the 1950s with modern digital sky surveys. They are painstakingly scanning images of hundreds of millions of celestial objects, looking for any star that was visible 70 years ago, but is gone today. Finding such a thing would be a smoking gun for extraterrestrial technology. The disappearance of a star would be a sign of technology so powerful, it is almost magical to us. One of the most famous ideas for a cosmic megastructure is the Dyson sphere. It was first proposed by the physicist Freeman Dyson back in 1960. Interestingly, he wasn't even thinking about aliens at the time. Dyson realized that any civilization's energy needs would eventually grow to astronomical levels. A star like our sun pumps out a colossal amount of energy every single second. But a planet like Earth only catches a tiny fraction of it. A Dyson sphere is the solution to this problem. It's a shell of technology built to completely surround a star, capturing every single photon of light, every particle of energy that the star produces. For astronomers like us, looking from the outside, a Dyson sphere would be a very strange object. The star inside would be completely hidden from view in visible light, but the sphere itself would get warm and radiate waste heat as infrared radiation. So, The signature of a Dyson sphere is a point in space that is dark in visible light, but glows intensely in the infrared. It would be a star that shines with heat, not light. Several searches have already been conducted, scanning catalogs of stars for this specific heat signature. So far, we've found some interesting candidates, but the search continues. Beyond caging a single star, a truly advanced civilization might set its sights even higher. I mean, why stop at one star when you could have a whole galaxy? This is the realm of galactic engineering. A civilization could build Dyson spheres around a huge number of stars in the galaxy. This would dramatically change the galaxy's appearance. Instead of a bright, swirling collection of stars, it would become a dark galaxy. It would be dim in visible light, but would blaze with the fury of a billion stars in the infrared spectrum. Astronomers are actively searching for these dark galaxies. Another reason for galactic engineering might be computational. Some scientists have proposed that an advanced civilization might turn its entire galaxy into a single enormous computer. They could use the predictable orbits of stars as a kind of cosmic clock. They could use the energy of the stars to power vast information processing networks. The galaxy would no longer be just a home. It would become a thinking machine. The evidence for this might be subtle, perhaps in the unnaturally ordered movements of its stars. The laws of physics are relentless. They apply to everyone, everywhere. Even a godlike civilization cannot escape them. The most important law for our search is the second law of thermodynamics. In simple terms, it says that whenever you use energy to do something useful, you always create some waste heat. Think about your laptop or your car engine. They get warm when they're running. This is unavoidable. The same principle must apply to alien megastructures. No matter how advanced their technology is, their galactic engines and stellar computers would have to radiate waste heat. This waste heat is our golden clue. It is the telltale glow that could lead us to a lost empire. While the civilization itself might be long gone, the heat from its decaying technology could linger for eons. This light travels across millions of light years, carrying a story. It tells us that something at some point in time was using a tremendous amount of energy in that location. It is a thermal ghost, a faint warmth in the cold of space. So, astronomers use powerful infrared telescopes to hunt for this glow. They're looking for galaxies that are far too bright in the infrared compared to what standard models of astrophysics predict. Light is the universe's messenger. It travels across the cosmos for billions of years, carrying information about where it came from. Astronomers are experts at reading this light. What if we found a fingerprint that did not belong to any known type of star? What if the light itself was unnatural? An advanced civilization might use giant space-based lasers for communication or for propelling their starships. If we happened to be in the path of one of these beams, it would appear as a flash of perfectly monochromatic light. Nature does not make light like this. Another technique is to look for strange pollution in a star's atmosphere. This is called stellar archaeology. What if a civilization used its star as a garbage dump? What if they disposed of the waste products from their nuclear reactors by dumping them into their sun? This might add strange elements to the star's atmosphere in quantities that could not be explained by natural processes. This search for unnatural light turns every star into a potential crime scene. We are looking for the chemical or optical evidence of technological activity. As we scan the silent cosmos, a challenging and somewhat dark idea emerges. It is called the Great Filter. This is a concept that tries to explain why we have not found any evidence of advanced alien life. The Great Filter is a proposed barrier, a challenge so immense that it prevents life from progressing to a galaxy-spanning stage. It suggests that there is at least one step in the long evolutionary journey that is incredibly difficult or even impossible to overcome. This filter is the great obstacle that silences the universe. The chilling question is, where in the timeline of life does this filter lie? Is it behind us or is it still ahead of us? If the filter is in our past, it means we have already overcome the hardest step. Perhaps the jump from non-living matter to the first simple cell is the filter. Or maybe the evolution of complex, intelligent consciousness like ours is the incredibly rare event. However, there is a more sobering possibility. What if the Great Filter is still in our future? This filter could be a self-inflicted catastrophe, like a devastating nuclear war, uncontrolled climate change, or a runaway artificial intelligence. The search for galaxy-scale ruins is deeply connected to this idea. If we find the ruins of many advanced civilizations, it would be a truly ominous discovery. It would be strong evidence that the great filter lies ahead of us, waiting. This brings us back to the heart of the mystery, the famous Fermi paradox. The physicist Enrico Fermi's simple question, "Where is everybody?" continues to haunt us. The paradox is the stark contradiction between the high probability of extraterrestrial life and the complete lack of evidence for it. The numbers are staggering. Our Milky Way galaxy alone has up to 400 billion stars. An advanced civilization would not need a huge amount of time on a cosmic scale to explore the galaxy. Even with technology just slightly more advanced than our own, a civilization could colonize the entire Milky Way in just a few million years, so the first civilization to arise should have been everywhere by now. Their probes should be in our solar system. Their artifacts should be easy to find. Yet we find nothing. No probes, no signals, and so far, no galactic ruins. The Fermi paradox forces us to confront some uncomfortable truths. Each possible solution to the paradox has deep implications for our own future and our place in the cosmos. The lack of evidence is, in itself, a piece of data. The search for galaxy-scale ruins is a direct attempt to solve this paradox. If we find them, it would tell us that everybody was here, but they are gone now. This would solve one part of the puzzle, but create a new, darker one. What happened to them? Of course, not everyone in the scientific community is convinced that we should be looking for galaxy-scale ruins. There is a healthy dose of skepticism, which honestly is a crucial part of the scientific process. Skeptics argue that the entire concept of a Type 3 civilization might be a fantasy, a projection of our own human desire for growth and expansion onto the universe. They question the assumption that all advanced life would follow the same developmental path. Perhaps a truly advanced civilization would not expand outwards, but inwards. They might upload their consciousness into vast virtual realities, living rich, complex lives in simulated worlds that require far less energy and resources than a physical empire. Furthermore, skeptics remind us that we should be very careful not to mistake nature for technology. The universe is a weird and wonderful place, and it is full of strange phenomena that we do not yet understand. A galaxy that glows brightly in the infrared might not be home to a Type 3 civilization. It might just be a starburst galaxy undergoing a natural, intense period of star formation. A star that vanishes might not have been dismantled by aliens. It could be a rare type of variable star. The maxim, "extraordinary claims require extraordinary evidence," is central here. We must rule out every possible natural explanation before we can claim to have found a ruin. This skepticism is not meant to stop the search. It is meant to make it more rigorous and scientific. There is another fascinating and honestly unsettling possibility we must consider. What if the ruins are all around us, but we simply do not have the ability to see them for what they are? This is the hiding in plain sight hypothesis. Think of an ant walking on the surface of a microchip. The ant would perceive the chip's intricate pathways and structures as just a natural landscape. It would have no concept that it was walking across a highly engineered object. Could we be in a similar position? Some scientists have speculated that certain cosmic phenomena we take for granted might be artificial. What if the regular pulsation of a pulsar is not a natural spinning neutron star, but a galactic lighthouse or a navigation beacon? What if the mysterious dark matter, which seems to make up most of the matter in the universe but which we cannot see or understand, is not a new type of particle? What if it is actually the mass of countless undetectable alien megastructures spread throughout every galaxy? This would mean the evidence we seek is not in one strange object, but in the very fabric of the cosmos. If a civilization is advanced enough, its technology might become indistinguishable from physics. Their engineering could be so profound that it sets the rules for how their local patch of the universe behaves. In this scenario, we are not just looking for a needle in a haystack. We are living inside the needle and calling it a haystack. We would be completely blind to the truth that is all around us. Sometimes a discovery comes along that makes everyone stop and wonder. In 2015, astronomers found something truly strange. It was a star, officially named KIC 8462852, but it quickly became known as Tabby's star. This star was located nearly 1,500 light-years away, and it was behaving like no other star we had ever seen before. Our telescopes, specifically the Kepler Space Telescope, had been watching it for years. Kepler's job was to look for the tiny, regular dips in starlight caused by planets passing in front of their stars. But the dips from Tabby's star were anything but regular or tiny. The star was dimming dramatically and at completely random intervals. Sometimes it would lose up to 22% of its brightness. This is a huge amount. For comparison, a giant planet like Jupiter passing in front of our Sun would only block about 1% of its light. So whatever was blocking the light from Tabby's star was enormous. Furthermore, the dimming events were not periodic. They happened at unpredictable times and lasted for different lengths. It was not the neat, repeating pattern of an orbiting planet. It was chaotic. It was a complete mystery that did not fit any known natural phenomenon. Scientists around the world were baffled. They proposed all sorts of natural explanations, but none of these ideas perfectly fit the data. This led some people, including serious scientists, to consider a more extraordinary possibility, an alien megastructure. The strange light pattern looked a lot like what you might expect from a Dyson swarm under construction. The irregular dips could be caused by massive unfinished pieces of a cosmic structure, orbiting the star in a chaotic cloud. This idea captured the public imagination. Tabby's star became famous overnight as the alien megastructure star. While most scientists still believe there is a natural explanation we have not found yet, this star served as a powerful reminder. It showed us that there are still profound mysteries in the cosmos, and it gave us a real-life example of the kind of anomaly that could, just maybe, be a signpost to a lost civilization. When we think about the search for other civilizations, it is natural to ask, what are the odds? How many alien civilizations might we expect to find in our galaxy? Back in 1961, the astronomer Frank Drake tried to answer this very question. He came up with a famous thought experiment that we now call the Drake equation. It is not a precise mathematical formula that gives a definitive answer. Instead, it is a way to organize our ignorance. It breaks down the big, daunting question into a series of smaller, more manageable questions. The equation has 7 factors. It starts with the rate of star formation in our galaxy. Then it asks what fraction of those stars have planets. Next, what is the average number of planets that could potentially support life per star? Then, what fraction of those planets actually go on to develop life? What fraction of that life becomes intelligent? What fraction of intelligent life develops technology that we could detect, like radio signals? And finally, the last and perhaps most important factor, how long do these technological civilizations last before they disappear? The problem is, for most of these factors, we simply do not know the answer. We have good estimates for the first few terms, but for the later terms, we have only one data point, ourselves. The equation does not give us the answer, but it does show us that the possibility of finding someone or something is not zero. As we ponder the great cosmic silence, we come to some truly strange and wonderful ideas. One of the most intriguing is the zoo hypothesis. This thought experiment tries to solve the Fermi paradox in a very different way. It suggests that advanced alien civilizations are not absent. They are here, all around us. They are aware of us. But they have deliberately chosen not to make contact. They are observing us from a distance, much like we observe animals in a wildlife preserve or a zoo. The idea is that there might be a galactic club of super-advanced civilizations. These ancient species might have agreed on a set of rules for dealing with younger, emerging species like humanity. The most important rule could be a strict policy of non-interference. They might believe that making contact with us too early would be destructive. It could disrupt our culture, our science, and our social development. It might be like giving a machine gun to a medieval knight. They might be waiting for us to reach a certain level of technological and ethical maturity before they invite us to join the galactic community. This hypothesis is both exciting and a little unsettling. On one hand, it is a hopeful idea. It means we are not alone, and the universe is filled with intelligent and perhaps wise life. But on the other hand, it is a bit creepy. It means we are being watched, studied, and perhaps judged without our knowledge or consent. The search for galaxy-scale ruins is more than just a hunt for aliens. It is a profound act of self-reflection. When we gaze out into the immense darkness between the stars, we are also looking back at ourselves. Every question we ask about other civilizations is a question about our own. Will we survive our technological adolescence? Will we overcome our divisions and work together as a species? Will we one day become galactic architects ourselves, or are we destined to fade away? The cosmic silence acts as a giant mirror, reflecting our greatest hopes and our deepest fears for the future of humanity. This quest forces us to confront our own place in the universe. For most of human history, we believed we were the center of everything. The Earth was the stage, and the stars were just a backdrop for our human drama. But science has shown us otherwise. We live on a tiny, fragile world, orbiting an ordinary star in a forgotten corner of a vast galaxy. The search for cosmic ruins is the next step in this journey of cosmic humility. In a way, the outcome of the search almost does not matter as much as the act of searching itself. The quest unites us. It pulls our gaze upwards, away from our daily conflicts and towards a shared sense of wonder. It is an endeavor that requires the best of us, our curiosity, our ingenuity, our patience, and our ability to collaborate across borders and generations. It is a peaceful, noble enterprise that reminds us of what we can achieve when we work together. So where do we go from here? The answer is simple. We keep looking. The search has only just begun. Our telescopes become more powerful with each passing year. Our ability to process vast amounts of data grows exponentially. The James Webb Space Telescope is already giving us a new view of the infrared universe, the perfect hunting ground for the waste heat of alien technology. Future observatories will open even wider windows onto the cosmos, allowing us to probe deeper and with greater precision than ever before. This is a journey without a final destination. It is fueled by one of the most fundamental human traits, curiosity. We are a species that asks questions. Why is the sky blue? What are the stars made of? Are we alone? This drive to understand is what took us out of the caves and sent us to the moon. It is what compels us to build giant machines to peer back to the dawn of time. The search for galaxy-scale ruins is the ultimate expression of this innate curiosity. It is the desire to know our context, to read the great cosmic story and find our place within its epic narrative. This quest gives us hope. In a world that can sometimes feel chaotic and uncertain, the search for intelligence in the cosmos is a profoundly optimistic act. It is based on the belief that survival is possible, that wisdom can be achieved, and that the universe is not inherently hostile, but is instead a place of infinite wonder waiting to be discovered. It is a bet on the resilience of life and the power of intelligence. Even if we only find silence, the act of listening, of looking, of hoping enriches us. It connects us to the generations that will come after us, who will inherit our telescopes and continue our search. The universe is under no obligation to give us answers. It may keep its secrets for eons to come. The ruins of lost empires may remain hidden, or they may not exist at all. But humanity will not stop asking the question. We will continue to scan the skies, to listen for whispers in the dark, and to search for the faintest glow of a distant artificial light. Because in the end, the search for others is a search for ourselves. It is a testament to our own intelligence, our own wonder, and our own endless beautiful curiosity about the magnificent universe we call home.